My journey to space started here in Bristol in 2013. I was attending the National Student Space Conference, which is an event that brings students from throughout the country together to talk about space. I was in the final year of my physics with astrophysics degree at the University of Leicester, and I didn't really know what I wanted to do with my life. I'd studied physics in the first place because I'd spent so long when I was a kid staring out at the stars, knowing how far away they were, wondering what was out there and how the universe worked. And then I'd look at the moon, and I knew that astronauts had landed on the surface, and they'd got to experience the feeling of running on the surface of the moon, but actually they were like leaping because of the low gravity. And I thought it would be super cool if you could experience low or no gravity. So I think I'm not the only one who's wanted to feel like this. And suddenly be really good at juggling in space. So this is Tim Peake. He's the UK's first astronaut for the European Space Agency. I'd like to ask all of you, have any of you ever wanted to go to space? Can you put your hand up? Okay, so yeah, that's like more than half of you. So my theory is that humans, we're all explorers. We all want to know what it's like to go to the next village, or to see a new city, to go on holiday and to climb a mountain and reach the summit. So I think this just shows how we all want to explore. Can you imagine the feeling the astronauts who first landed on the moon must have felt looking back at the Earth? So this is a picture of Buzz Aldrin and Neil Armstrong returning to the moon orbiting vehicle from their first landing. This picture is particularly amazing because in it you can see everyone who had ever lived on Earth up to that point, except for one person, Michael Collins, the astronaut who took the photo. So we come back to when I was in Bristol at the conference. I was in my final year, I was having a bit of a crisis, didn't really know what I wanted to do. In the space of about a week, I'd gone from wanting to work in HR to wanting to be a dentist, to watching Too Much Time Team and wanting to be an archaeologist. So one of the things I think is most amazing about this conference was there's so many people that I wanted to talk to. There was this guy there who was an engineer, he was working for his company, trying to recruit other engineers. And at the time, I didn't know that I wanted to be an engineer. I thought it was all guys wearing hard hats. But actually, now I am an engineer. I've only worn a hard hat once for a joke. You can see in this picture we couldn't find a clipboard like all the other ones had, but we did find a tape measure, so very useful. One of the best things about my job is working in a huge team with so many different people. Because the thing about space is, none of this can happen with one single person working on their own. And I think the pinnacle of this achievement, this collaboration, is the International Space Station. Now this thing is absolutely massive. It's 100 meters in length. And it's been a huge collaboration with so many different nations. From the United States to the European Space Agency to Japan and Russia. And the other thing is, there's so many people who've worked on this to make it work. So with a space mission, you start off with the science team who decide why you're going to do this, what science you need to do, and what you want to discover. You then send this information to the engineers who build the thing for the scientists to find out what's going to happen. And then you have all the people who help the engineers do the jobs. You have the managers, you have the finance team, you have the sellers and the buyers, you have the lawyers and the politicians who implement the policies to make this all work. And then when you've got the thing in space, you have all the people working on it to keep it running. So not only do you have the astronauts, but you have a team of people in constant communication with the International Space Station, 24 hours a day. You have the doctors, the psychologists, making sure the astronaut's okay, and everyone looking after the health of the workings of the International Space Station. But you might think, why do we do this? Well, firstly, I'd like to talk to you about some of the cool technologies that have come out of the International Space Station. So the first one I think is really cool is the water purification system, designed to save the astronauts' lives on the International Space Station, has been deployed in regions where they don't have access to safe, clean water, giving people access to the stuff they desperately need. The second technology I think is really cool is the research has gone into preventing osteoporosis and muscular dystrophy. Because when the astronauts living on the International Space Station, they lose some of their bone density and some of their muscles. And this research has provided treatments that we desperately need. The third thing that I think is really cool, the robot arm used on the International Space Station. So the technology from this has been used to operate on tumors that had previously been inoperable. Now, the reason these were inoperable were because you can't operate on a person inside an MRI machine because the surgeon can't get in there too. But with a robot arm, you can. So think how many lives can be saved from this technology. So, as you can see, all this technology is used not just for exploration, but for helping us here on this planet. The other thing that we use satellites for, we can look at exoplanets to search for life, we can look at the sun, we can look at other stars, we can do research into gravity, to name just a few. But one of the things I want to mention is Earth observation. So looking back at our own planet. One of the things we can use this data for is natural disaster response. So this is when the authorities have the data they need to save people's lives from stuff like earthquakes, floods, volcanoes, and hurricanes. So this is a picture from a satellite showing Hurricane Harvey at the end of last year. Now, this data allowed the authorities to plan where or predict where the hurricane was going to go, so they could evacuate people from these cities. And the next thing I'd like to mention is forest fires. So this is a picture of Mount Vesuvius, and although it's a volcano, it's not erupting. These fires are in the forests around the edges. So using this data, we can see where the forest fires are and potentially stop them. So the next thing that I'd like to talk about is climate change. So we can use this satellite data. So this is a picture of the land surface temperature over a number of months. And you can see it changing, and we can use this information to inform our understanding, to inform our policies, to enable us to protect our planet for a sustainable future. But the thing that I find the most exciting about space exploration, think how many children were inspired by these moon landings. They were watched on television all across the world. Kids were brought downstairs, woken up in the middle of the night by their parents to watch the grainy footage of Neil Armstrong taking the first steps on the moon. There are people alive today who could land on the surface of Mars. But this can only happen, as with the International Space Station, as a huge collaboration across all of the world. We have to work together to make this happen. Like how my journey started with wanting to know how the universe worked, all this is driven by our need to explore. In 500 years, the things that we're going to remember aren't the complicated politics of today, but the things we can accomplish together as humanity. How we looked after our planet and how we looked after each other. Thank you.